Okay, so today we are going to do some trig derivatives. And we already know a couple of them, but we're going to investigate 3 more today. And then in class on Tuesday, I'm going to let you guys do some problems by yourself. So let's get a blue pen out here and let's title our page Trig Derivatives. Yay! I have to work on my handwriting there. Okay, so we already know that the derivative of sine is equal to cosine. At least most of us know that. And we also know that the derivative of cosine is negative sine. Of course, if we happen to put a negative in front of that sign, and we wanted to find the derivative of negative sine, that's no big deal because that's just like our constant multiple rule. We can take that -1 out in front of the derivative, and we'll call it negative derivative of sine, which of course is just negative of cosine of x. Of course, you could do the same thing with cosine, and the derivative of negative cosine, pull the negative out front, and then make the derivative of negative cosine positive sine. Okay, so what we want to do now is we want to find the derivative of a new trig function, the derivative of tangent. So here's an example. And we have been doing, what we did on Friday, we did the quotient rule. So I'm going to write tangent as a quotient. Does anybody know what that is? Tangent as a quotient? It's just like Blue's Clues. I'm here all across America. That's right. The derivative of tangent is sine of x over cosine of x. Give yourself a pat on the back if you knew that. Alright, so since I can rewrite this as tangent equals sine over cosine, then I'm going to find the derivative of sine over cosine, and that will give us our derivative of tangent. And we have a quotient, so we're going to apply the quotient rule, of course, which is low d high minus high d low over low low down below. So we're going to do the derivative of sine of x over cosine of x is equal to the bottom times the derivative of the top. So I'm going to have cosine of x, which is the bottom, times the derivative of sine, which is cosine, and then minus the top times the derivative of the bottom. And of course, the derivative of cosine of x is negative sine. And this is all over the bottom squared, which is cosine squared. So let's see here. Let's clean this up. In the top, I've got cosine times cosine, which we're going to write that as cosine squared. And then I've got negative sine times negative sine, which is positive sine squared. And that's all over cosine squared. Now on the top, I've got a Pythagorean identity. I've got cosine squared plus sine squared. And of course, nobody would cancel those cosine squareds because that would be silly. We can't do that because of that plus sign. So let's take a look. Does anyone know at the top what cosine squared plus sine squared is? What that Pythagorean identity is? Anybody? Get off of Facebook and don't minimize me. Get back in here. Cosine squared plus sine squared, that is equal to 1. So we have 1 over cosine squared of x, which is, of course, secant squared. And that's what we're going to call the derivative of tangent. The derivative of tangent is secant squared. If you're not up out of your chair right now clapping out of sheer joy, there's just something wrong with you. That's pretty cool. So now we have another one. We got the derivative of tangent that's secant squared. Okay, extend the page here and let's do 2 more. Let's see, we are going to find now the derivative of, let's do cosecant of x. And again, I'm going to write this as a quotient. Of course, cosecant can be rewritten as the reciprocal of sine. So cosecant is 1 over the sine. So we're going to have the derivative now, again, of a quotient. And so we're going to apply the quotient rule. More practice. Let's just go ahead and do that then. So we've got the bottom times the derivative of the top. The derivative of 1, of course, is 0. Minus the top times the derivative of the bottom. And that's all over the bottom squared. All right, let's clean that up. So we've got negative cosine on top and then sine squared on bottom. And that is our derivative, but it's usually not written like that. So let's see if we can't separate this into two fractions. We could write this as negative cosine of x over sine of x, and then times 1 over sine of x. Notice if you multiply the tops, we get negative cosine. If you multiply the bottoms, we get sine squared. But the reason that this is changed like this is because we now have two trig functions. Cosine over sine is negative cotangent, and 1 over sine is cosecant. Now in your book, it's going to flippy-floppy these things. I guess because of alphabetical order, I don't know, but in the book it's going to write cosecant first and then cotangent. And if we're multiplying, of course, it doesn't matter. So in most textbooks, you're going to see that the derivative of cosecant is negative cosecant x times cotangent x. Uh-oh, my dog's in there barking at. There must be somebody across the street. He's going to save me. Don't you worry. And if you didn't hear my dog barking, then I just sounded crazy there. Anyway, so we have one more. Let's find the derivative of secant of x. Same approach. We're going to write this as a quotient. That's 1 over cosine. So let's just bust this derivative out. Hi, Cole. Yes, you're going to save me. Thank you. That's a good boy. Okay. So I've got the bottom times the derivative of the top. Of course, the derivative of 1 is 0. Minus the top times the derivative of the bottom. All over the bottom squared. So let's see here. Of course, cosine times 0 is 0, and negative 1 times negative sine gives me positive sine of x. And in the bottom, we've got cosine squared. And that's our derivative, but we're again going to change this into two fractions. One of these fractions is going to be 1 over cosine, and the other fraction is sine over cosine. And now we have two trig functions. 1 over cosine, of course, is secant, and sine over cosine is tangent. And so the derivative of secant, oh, my dog wants his tennis ball. Hold on, Cole, I'll get your tennis ball. The derivative of secant is secant tangent, and we are done.